Cool.
Hello, hello everyone. We're live now on Data Science Office Hours. So happy to be back here with you guys discussing the great field of data science. So right now, I'm here with Kristen and with Tari too. Okay, I hear myself. This is very weird. All right, so this topic and the topic of this session will be automatic machine learning. And we discussed this last session. Bo and I were talking about different things about our experience on AutoML and what we did with it and what's the thing we've been thinking about it and stuff. If you want to see our experience and thoughts on the subject, just please go to the last session. It's on YouTube. And don't forget to subscribe, because if you subscribe, you can get all of the different uh, notifications and stuff. All right. So right now we have a new member of the team, and she's Kristen, and I'm gonna let her introduce herself. All right. Hello.
Hi guys, I'm Kristen Kerrer. A little bit of background. I have been in data science for the last 8 years, working in a couple different industries, and I'm currently working for Constant Contact, which offers a email marketing solution. So doing a lot of interesting work around that I'll get to speak a little bit more to tonight. My background is formally, my educational training is in math and statistics. So my master's degree is in statistics. And so I'm sort of coming from that side and have learned the more programming side over the course of my career. And I'm really excited to be here.
All right. Thank you a lot for joining, Kristen. And now we have more girls now, so it's better because this is what data science should be, and a section for equality, and there's a lot of great places for being a woman right now in data science. There's blogs and meetups for only girls and women in data science and stuff. So just join. All right. So we're gonna start the session. We have Tari back again. He was traveling a lot in his amazing life, just trying to do a lot of things with deep learning. And all right, so we're gonna first talk about your experiences with automatic machine learning. So I think Tari can go first, and
Sure.
he has a lot of things to say right now. So it's up to you, Tari.
All right, thank you, and great to be back. As in, the last couple of weeks, lots of travel. I think AutoML is a huge discussion, also for us in Deep Kappa, where we're writing a bunch of papers, research papers, and new algorithms. And I think so. It's like a double-edged sword, if you ask me. So AutoML is definitely the direction where the industry is heading. We know this. Having been in this industry for almost 20 years, you see a technology sort of trend coming in. There's a lot of customization. If I look back almost 18 years back, I was just joining the industry, was fresh out of university, or a little bit. I did my physics and astronomy some time ago. That's quite a while ago. I was still fresh, I mean, calculus never went away. That's why we're back. But I think so. Just an example of virtualization industry can give you a bit of perspective. In the time where the industry was moving from converting all these hardware resources into software, and what happened back then, we were doing a lot of customizations on how to create and how to sort of have software disks, as in just your virtual disks, virtual memory, virtual CPUs, and all that stuff. What we saw was, in the first couple of years, there was a whole lot of customizations. There were a lot of, let's say, emotional kind of baggage which every software carried, because it was all the babies which developers were building themselves. I think if you look at the deep learning industry, just coming, fast forward to the deep learning industry or machine learning industry or whatever name that people might want to label it, is that there are a bunch of developers came up and released AutoML. I remember there was one French a developer. He had released an AutoML. It still is out there, and slowly when I saw about Cloud ML or Google's AutoML, yeah, things like neural architecture systems, etc. It started giving me confidence that well, I shouldn't be too negative about the whole AutoML, because as a developer, I mean, I've never left being a developer. You realize that there are a lot of things you don't want to do, right? For instance, if you look at hyperparameters, today, if you want to do a parameter search, you have approximately around 110 to 115 hyperparameters you may have to tune. There's a whole lot of optimizers and cost. Obviously, we have good, a great cross entropy cross function, which is great. But optimizers and the family of optimizers and how to marry optimizers together. RMS prop. You want add Nesterov. You want to add momentum. So there's like 20, 30 different variations you can have with that. Now you can imagine if you try to have all your hyperparameters, tuning that, and putting all optimizers together, it's almost like I need probably 100 machines with lots of computing power and GPU to just work on one problem. So from that perspective, how do we find a balance of combining these and bringing these together so as to solve the problem that I have? For instance, even yesterday, so just give you a fresh example, you guys, you're all watching this and just want to give you really fresh. So last night I was talking to CEO of a company in US, and they have, it was mind-boggling. So they have data. It's an 18-year-old company or something. And it's a medical company. They have data of about 15 million patients. So 15 million patient data. We're right now working on legal stuff and how to sort of release that data set. It's a huge data set. It's almost like, we're thinking of some kind of a Kaggle competition. And it's huge. So, we're going to be launching in the next couple of weeks or months. So we're just going to have to figure it out. Now, it's impossible for us to sort of, get that data set and try to, let people just go the way they used to go 2 years ago. So there has to be some kind of, we're trying to already think of, have people, give them some AutoML kind of libraries and tell them to practice with those. And this practical example is telling me one thing, that I cannot boil the ocean. I cannot continue to boil the ocean. It is important to focus on an optimizer which you may have written. And then I think it makes sense to customize that part of your solution. And it's called a cache problem. I have it written down here, so I'll just sort of explain what that is. So cache problem basically means is a combined algorithm selection and hyperparameter optimization. So this paper was written, I can show you. It was written by a bunch of German researchers, and they're explaining, and it makes sense. I mean, when you think intuitively, you don't want to babysit like 20 models. You want to have some kind of a solution in which 3 top AutoML solutions that you already have figured out. You take these and you deploy these 3 top guys, and then basically you come to your solution. So in my experience, coming back to your question, I think the important thing is to find a balance. We're not actually still at that point in the industry, as I mentioned, in the other industrial shifts that we had in technology. We are not still there. If you look at Google Cloud, AutoML, or there are a bunch of other solutions, I think there's another company called Clarify AI or something. And there are a bunch of other small firms also starting with this AutoML. Things are getting sophisticated, which is great. There needs to be some kind of a view in which you have a view, where you can look under the hood, and at the same time, say the 80% of the things. For instance, you have data ingestion, and all the way you need to have outcomes. So all that feature engineering. I wish, there were solutions in which we could have AutoML. So you bypass the whole thing and you just say, this is my data set. Boom, I apply it and I get predictions. because this is where we should be moving in the industry as well. There's a ton of things happening. Healthcare industry is sort of moving a bit slower. Autonomous vehicles and automotives are moving super fast, which is great news. But I think we want healthcare to move fast because we're talking about huge amounts of healthcare data where people are talking to legal authorities. And I foresee in the next 2 years, there's going to be a ton of healthcare data, which is great news for deep learning and machine learning engineers. There's going to be a lot of jobs, so that's great. I mean, that's what we're pushing as well. I'm pushing individually, personally. And I think it's best to start moving towards the AutoML route. So people start applying and deploying solutions based on the top stars, right? Atom is your top optimizer. I mean, so let's try to kind of move in that direction. So we already have this move where people are making some choices and automating your machine learning and deep learning algorithms and everything that you have to do in between can sort of, start moving to the back end of whatever that was. You wanted to do all that stuff, and now you have technology and libraries that solve that problem for you. So my experiences in the projects that we're doing, we are slowly moving towards automating stuff because we cannot do like 20 projects, with a bunch of researchers that I have, and expect everybody to meet the project deadlines. So for us, it's practical, and for the client as well. I mean, we're talking to end customers who say, "Hey, listen, so you have a great solution." There's another customer where I'm meeting. We're trying to raise about $1 million for a project, and I have to present my story to the bank, and so these people don't care about what kind of optimizers you use, so it's very important to explain to them in terms of input that, okay, here's the data, because that's what they're interested in. So how do you sort of convert just data like images of cytology or histology from pathology sort of data, and how do you give me sort of a diagnosis as to, well, is this mammography, is this breast cancer, yes or no? So I think it's very important to sort of bypass this while understanding fully what is under the hood. So if you do not understand it fully, what's under the hood as of yet, as in maybe 2-3 years from now, it wouldn't matter. But for now, I think as a machine or deep learning engineer, it's very important for you to focus on what is under the hood, what is being automated, because things are still kind of being baked. They're still in the oven. So I guess in a year or two, it would be good to kind of keep an eye on both these. So I would say, start exploring a bunch of libraries, start automating things, and also start, even explore. I went on Google's CloudML website, where Fai Li, she's also explaining as to how this is. So I think start getting familiar with AutoML, and I think you're definitely going to see a lot of interesting things. I have some pros and cons I will discuss later, but I hope this is I hope this sort of answer helps you guys get started with this session.
All right, that was a great introduction to the subject, and we did some of a kind of a similar thing last session. So if you want to check it out, just remember to do that. So now, Kristen, what about you? What about your experience right now with AutoML, and how you use it in the past, or how are you using it right now?
Yeah, so I think, in the past, I have the experience seeing it both ways. Like 8 or 9 years ago, when I was building ARIMA models, I had to fit all the autoregressive and moving average terms myself. And now I just worked on a project where I was identifying the seasonal customers with a seasonal usage pattern in the database. And, I pulled usage data for 300,000 customers and used a loop and looped through an AutoML and, extracted the seasonal, whether or not the person was seasonal, tagged that, and I'm able to upload it to the database. And, when I think about just how far we've come, I couldn't have done that 8 or 9 years ago. And, 8 or 9 years ago, building 100 models was like a big deal. And I just built 300,000 and we're able to action on that. And it took a very short time because, the data aggregation that I had to do there wasn't a lot. I just needed, the month, the year, the usage and who the customer was. But, you know, another opportunity that's coming up really soon, you know, I walk into work today and my boss is like, you know, I need to talk to you. The CEO is now really excited about the customer segmentation project that you're going to do. And so a couple weeks ago, I had started talking to different areas of the business because not all of our data systems not everything's in the data warehouse, right? So I need to get data from other areas, plus I need to hop into the big data environment and get data there. And so, you know, I'm working on pulling this set together. And, you know, so then I hear that my boss would like me to be able to deliver something in 3 weeks. And, you know, so thank God that there are auto feature engineering tools, which I haven't previously used, but I'm going to be installing some libraries tomorrow and giving it a go. You know, so, you know, that and the ability to, I just remember how much time I used to spend doing exploratory data analysis. And now I can go into Data Explorer in R and I can look at, you know, all my variables and the percentage of that variable that is missing data. And I can look at a correlation matrix and I can look at box plots and I can look at scatter plots and all those things that like I used to write individually and look at each one individually. And now I write, you know, a couple lines of code and I get a nice markup and I just look at it. And I think it's fantastic. And, you know, because it allows me to provide value sooner. And, you know, these things that, you know, the business never really understood before, like, okay, you know, it's going to take me a couple weeks to just do the feature engineering and clean up the data and stuff. You know, and I think we're moving to a place where I'll be able to, you know, spend more time talking to the business and automating a lot of the things that after you've done them a couple times, well, I still get really excited about feature engineering actually, and like thinking of creative solutions, but like I'm really excited that there are packages available that allow me to do my job more efficiently.
All right. So on touching the point you guys just did, I think Terry is frozen. I'm not sure. I don't know if okay. I'm seeing him. Okay, I see you now, Terry.
Okay,
you're back. All right. So one of the things we covered last time, and I want to see your opinion on this is, so right now there's a lot of people. I mean, I've been talking to people that says to me, so if we have auto machine learning and now in like 10 years, maybe some AI will be writing Python code, what's the point of having a data scientist in your company right now? Or is this auto machine learning will substitute the position of a data scientist? So maybe your first, Christian, what are your thoughts on this right now?
Making sure I'm not on mute. So I'm not worried about that. I think my experience has been that every time new solutions and new technology comes around, it's just allowed me to work on more higher value projects and opportunities. And so, you know, going back to the seasonality, picking up seasonal customers, you know, without a data science background, I wouldn't have known that that was a potential solution that we could have used. And the questions that you're asked as a data scientist are not always the most straightforward questions to answer, you know, and thinking about the approach is and collaborating with the business and being able to present the results in a non-technical way, I think still is going to require some level. Am I going to need to code as well as I used to? No, I'm not going to have to. Some of those things are going to get simpler. Things are going to get faster. But I don't think the need for people like sitting in this space who have deep knowledge of this, and there's still, you know, absolutely going to be other things that we do as data scientists, like designing tests and appropriately running tests and being, you know, the resource to the business on how they should be doing that. And those other scientific things, like, I don't see those going away because they're very specific to the domain knowledge of the business. And, you know, I think what I do on the day-to-day will change, but I don't think that the need for me and my set of skills will change.
Right. That sounds good. So what about you, Terry? What are your thoughts on this subject?
So I probably have a bit different sort of view. I think the acceleration to make a whole lot of let's say, you know, if you have 10, 20 steps between input and feature engineering, pre-processing, and eventually sort of outputting data. So I think if things get automated, you know, data scientists or aspiring data scientists should really start looking at other domains as well.
Oh, really?
So I think it makes a lot of sense. If you're inputting image data, text data, audio, speech, you know, all combinations of those, you're going to see, you know, for instance, example of a Google release on the NLP data, which is where there's a whole lot of, so the next couple of years, next 2 to 3 years, is going to be 2 areas which will be super interesting for data scientists to really start getting better at. You know, if you stay where you are today, which is, you know, still great, is no problem. I think 2 areas is the NLP, with, you know, for example, Google's universal sentence encoder, where, you know, things like Google Duplex is based on, and a lot of other things that are going to happen will be super exciting. So, you know, diversifying or expanding your skill sets into sort of trying to do a startup or be in a startup and get more ideas, how to sort of build a product and solution is going to make a lot of sort of difference. That's one. The other area is deep reinforcement learning that is, you know, that's gaining a lot of traction again. So the next couple of years, there's going to be a ton of stuff. So for example, the model, you know, the worldview, where Google is also sort of, just happened to just mention one company's name. That kind of scares me because there's one company taking a lot of important, interesting strides. Well, so is Facebook's research as well doing. You know, Facebook has been in the news for different, you know, not so good reasons, but I know my friends in FAIR, they're doing really good work there as well. So, you know, just to mention a bunch of other names of companies as well. But I think, so from domain perspectives, it would be good to kind of move into these 2 areas and get better, because the data sets in NLP, for example, just spoke about 15 million patient data in EHR that is an NLP data. So there's not much sort of going on there in terms of Kaggle competitions or stuff like that. So it'll keep data scientists busy to learn these skills. So that is a good thing. The next couple of 2 to 3 years or 2 to 4 years probably will be interesting. What I do have a little bit of not a pessimistic, but definitely sort of a word of caution towards the future is it is going to, see, the automation is almost like, you know, you think of an industrial revolution. So you have these steam engines, and today you don't even care how you travel. So, and the same thing is when your machine starts writing code. For example, if you're a web developer or a designer, you can make a whole bunch of Photoshop PSD files, right? And you can convert all that into code and even translate everything and convert it into a website, full functioning website with like 30 pages. You can do that already. That has a huge impact on people who are sitting and coding, and who, if you're a freelancer, if you're a software company who made a lot of money doing this, you're basically gone. So I think from that perspective, you got to stay on your sort of, guard, and there's a lot to learn. So fortunately, the sophistication of the applied mathematics and putting your efforts into improving deep learning systems. So for example, Capsule Networks, there's a lot going on this year. We are writing a bunch of papers. I can give you examples of two sort of papers that we are writing, just to give you a bit of a flavor before we release these. Probably not in NIPS this year, but there'll be a bunch of conferences in US and in Montreal and Canada where we're going to be going. So switching between, for example, your optimizers. There's not much happening there, so we're writing a deep switch. The paper is sort of nicknamed internally deep switch in our firm. And how to sort of switch between optimizers while you're running your epics. So that is one. The other is sort of learning rate kind of dilemma. How to optimize your learning rate while you are in this huge loop of 5,000 epics where you're doing some huge NLP, recurrent neural network kind of sort of a project. So from that perspective, you have to choose. So there are ways to differentiate it to get better at your game and start shifting the industry because you're being part of some new sort of deep learning algorithm and ecosystem. If you stay where you are, I think the problem is that those things will be automated. And AutoML is going to change the way you work. So as Christian also mentioned, there's not a ton of things. It's exciting. A couple of years ago, it's exciting to understand how libraries are built. So I want to, do all kinds of interesting things with the data that I have, pre-process, reshape and all that stuff. And now if that has already been taken care of, I should sort of accept the fact that I said, okay, what is the other sort of higher goal that I can go and sort of continue to differentiate myself? What I do worry, I cannot predict, but I can tell you this is that the acceleration in which things get automated, the loops are getting smaller. So, back in the day, 20, 30 years ago, we had databases and things moved like super slow. Software and internet made things like super fast. Competitions, which I think is an amazing way to solve problems, are reducing sort of those cycles even faster because, in these competitions with this cash, other sort of incentives and sort of appreciation of who you are, anybody from anywhere can come up with a better solution than you are in this world. Internet kind of makes that happen. So that should be, I find it super exciting because I'm running a startup. So for me, there's a huge ocean, and I'm looking like, wow, there's a lot for me. But if you are a data scientist, you work for a large publisher, or you're a data scientist working on automotive or some other company, you have a limited role, I think I would worry if I were you. And I just want to be very honest, because we're sitting inside this cubicle, there's this big company you're being part of, or some big sort of telecom company, what have you. With your limited role, which is going to be automated, if you haven't stayed up to speed, I think in the next 2 to 3 years, you may run into problems. So don't sort of, you have to differentiate, spend your offline hours, office hours to learn the things that I mentioned, like deep reinforcement learning, go deeper, super deep into it. Go, in NLP, you have to spend the next couple of years really getting really great at it, which is great, then you can take a lead there as well. And there are going to be a whole lot of new jobs where you could probably transition in the next 5 to 6 years into becoming a space engineer with some great ideas, because space industry is expanding dramatically. So, people should pay attention to that, not just think of, oh, I work for a telecom industry. It's a telecom industry. Look what's happening, right? AT&T, they just got approval to buy Time Warner, and then you have Comcast going after, I forgot the name of, Fox channel, Fox Business. So, these industries are consolidating. There is no way you can be part of this and differentiate this. I'm a telecom expert. That kind of a job is going to kind of go away. You're a sort of vehicle design expert, sort of visualization sort of artist, and all these sort of fancy terms which today we think are stupid, is going to be like a super cool job in the next 5 to 10 years. So I think differentiating in terms of learning the things that today are sounding niche, but in the next couple of years will be mainstream in those domains, in deep and/or machine learning. Keeping an eye open to sort of be part of things outside your office hours. But this is data science office hours, so and it's early morning here in Amsterdam. Why do I wake up and why do I come here and want to share my experiences? Exactly that. and Christian and Fabio, they're on the other part of the globe. We're it's late in the evening, and we're doing this because we believe this is what is going to make your career sort of exciting. So and looking at these domain expertise and looking for sort of new skill sets that you need to hone. We've spoken about in the beginning of these data science hours how important it is to make presentations. You have to get sophisticated in what you do. And there's a whole lot of scope for myself as well. Continue to kind of improve on your skill sets, become super well-rounded instead of professional. And I think you're going to do a lot better than your peers, because this battle has just started, and it's going to be quite aggressive. There are still the big things, which are unstoppable, like companies like Google or Facebook or Amazon. They're increasingly accumulating the best and the brightest brains to themselves. This is not going to stop, no matter what. Industry cannot complain. The lobbyists and even university kind of level all over Europe as well complaining, oh, we're losing smart professors and smart teachers and smart students. I said, well, these guys are going to go there because there's lots of fun stuff happening there. So I think it's also, and this is sort of my plea to the industry, I talked to sort of industry leaders in enterprise world, is to continue to sort of motivate and give more space and room to your AI or machine learning departments. Give them more autonomy.
But here is something where you're talking is, and it's kind of weird. Maybe some other people have this same question right now. Is that okay? So some people in the world are building these systems. They're like, you can count them with the fingers on your hand. And these people building these systems, they're gonna release them into open source, or maybe sell their product and things. So you, as data scientist, as I was listening to you, I thought of two options. So the first one is if you're a researcher, maybe you're okay. And this is one of the things I think I heard from you. It's like, okay, if you're researching in these areas, I think you have a lot of work to do in the next 5 to 10 years.
Yeah.
And if you're a data scientist right now, you should choose a lot of these different things that are there right now, and just be there, be present in the area and do things there. Not just be this holistic data science view we have right now, where we are just like doing all of these different things. And this is, for some people, I think this is quite a different task to do, because some industries, and I've been in this kind of interviews, they're expecting both things for you. They're expecting you to be a researcher and for some reason an expert in all of these like applied areas. So it's just very hard for people getting into the field right now, because the industry or most companies I've seen there are not aware of the big gap there is between researching and doing things. And it's not the same right now. So I think if people here and there, if you have questions or things, this can be a moment to ask them. But this is quite a different way of seeing things right now, because so people can say, yo, I'm gonna be a researcher and I'm okay, or no, I'm gonna start a startup and I'm gonna be okay. But those are very different parts of being a professional in the future. So I don't know. Do you have something to add here, Kristen or Tari?
Yeah, maybe let's pass it on to Christian. I think you make very good points. Just to close my what I was mentioning, I think yes, and you make a very good point. Expecting a data scientist who's entering in the industry and they hear like, okay, well, welcome. Potentially in the next 2 years, this train is not going to go anywhere because, well, AutoML is killing all these jobs. That's not what I'm saying. I'm saying there's still a lot of room to play. And I think it's really important to see who do you want to be, right? Yes, you're right. If you're a researcher, I think you're on a great track. In the next 10, 15 years, maybe next 20 years, you're really covered. Not anymore like researchers used to sit in the labs. Today, labs are being sort of democratized. Your labs are coming inside the heart of industry. in the heart of companies, and they're saying, okay, put this R&D at the heart of our decision making and change this world. And who wants to be with me? That's what the CEO is asking these days. Being a traditional data scientist is also going to change. So I think how we're talking about data scientists' role today is going to be very different from the next in the next 2 years. I would say convergence of these two roles and creating something different. I don't know how that would be labeled or called. Would make a lot of sense. So I do agree with your point. It's what I'm trying to say is converge. Do not stay in the silo. No matter how niche and how exciting it looks, and makes a lot of sense to add data scientists to your LinkedIn logo or your CV, provide answers and solutions to what you're doing, which are unique and exciting, and that'll help. Christian?
Yeah, no, I completely agree with what you're saying, and especially with the silo. I think that that's, something that you want to keep at the forefront throughout your career, regardless of sort of where you sit. And, I've always hopped jobs every 2 years because I was looking for that next exciting thing and to extend my repertoire of, things that I could do and try and become that well-rounded person. And I think, I see what you're saying as well with the velocity with which these AutoML products are developing. But at the same time, I think that, when we look outside of those top tier companies, you have a lot of companies where their data is siloed and they're working to get a better data warehouse and they're working to get a better big data environment. But I think that they're probably going to move a lot slower than, the solutions that are being provided for them to utilize.
Yeah, I think that's a good point. And I think it's very different. I mean, I've been working in Mexico and Venezuela and all of these different countries, and we're moving slower because we're waiting for a lot of things to happen. And I can see the things you're saying right now, Kristen, because people right now are trying to enter the digital area or the data science area just now. I mean, there's some companies that are just starting this year with data science. So, but on the other hand, I'm thinking, okay, so I'm company X, and I'm gonna start my data scientist team today, and I hired 2 or 3 guys, great people in the country, and I have them here. And the next year, a great company like Google or something like that will come to me with, hey, I have this solution built where you don't need anyone else. So what's gonna happen there? And if you're not a developed country or things like this, you're still gonna be try to enter in this maybe niche of companies, and they're gonna try to take you with them. And so I think even though if you're not in a country where data science is as advanced as in the United States or some countries in Europe, I think you still should be kind of worried because it can happen sometime that a big company will go to your company and sell to them this whole picture, this whole solution thing, where you can get into trouble. Because if you're starting in the area and they're gonna maybe just sell something very cheaper than because we're not cheap people.
No.
Normally the scientists they're being paying a lot of money in every country, I think. So maybe you should get to the state of the art in every of these areas we mentioned in this session, because if you're not doing that, maybe you are in trouble.
I think this is actually the amazing point you make, Fabio. This reminds me when I was working at the university here in the north of Holland, one of the top universities. This was like, I don't know, 12 years ago or 13 years ago. Google, this is back then, right? So Google was shipping an appliance. I still have a picture. Maybe I should post it one of these days on LinkedIn. I'm holding this big blue kind of a server in my hand. It's like flat server, like a HP, just, I don't know, people, if you've used and held an HP server in your hand, a DL, 360 kind of a server, really flat, like a pizza box. And you could just sort of plug it into your data center and you could optimize your search. And so for us, I was managing this huge, not a MOOC, but a learning management system for the university. And that was a solution which Google was already shipping, telling that we're the masters of search. And we're going to provide you with all this, our search algorithm custom built inside this physical box. In the defense of the data science industry, where we've been probably maybe painting a picture like, don't, it's going to be changing, it's going to be scary. I don't think we should worry too much either. So they did ship that box. We bought it back then. Didn't really help much because there's a lot of customization inside your customer environment. I'm not really sure if those boxes sold the way Google had planned to sell. Now, I'm not saying that history is going to repeat itself in the sense that, well, they're going to create an AutoML box, a nice, fancy-looking sort of thin pizza box which you can plug into your data center, and it won't fail. It did fail in the past. It hasn't sold like, sort of pancakes, and people just said, okay, well, you could have anything in here. You got finance sort of applications, you have learning management system if you're an educational institution or something else. And search is like super important as to knowing who he is. In any context, search is super exciting and important. It didn't help us, at least. I think it still is there, and maybe it took some time to improve. Did it really kind of dramatically change the way the application, this huge application that we were managing? Not really. It did help a little bit. So even if Google ships, and I think they will, I think they definitely will. Believe me, this whole TPU thing which you're seeing right now, so tensor processing units and everything they're building in your data center, it will come. I totally agree with Fabio. It is going to come into a CEO's office without people, and I put myself with the same group of people, like us in the machine learning department, that there is, a box that is gonna sort of, kind of try to be smarter, cheaper, maybe a couple of $100,000, even if it's $1 million a year, kind of a subscription, it saves you from hiring 500 or 20, even 20 data scientists. 500 is like a huge number. And so, paying, I don't know, $100,000 or euros, or maybe in developing countries, probably it was 50. Even this is a whole lot of money. So it's something which we should be, well, we cannot stop it. So automation will make things a bit sort of easier. Now, which are the parts that is going to sort of change? I don't know. I'm just hoping that the customization, and when I say customization, it's not like a roadblock to the innovation. We should continue to innovate. I mean, customization is, what is the context of what you're building as a model, a deep learning or machine learning model, for the customers in a business to business or business to consumer space that you want to improve. And this is where your differentiation, maybe I should use that word, so customization, differentiation is not where these big companies will be able to cut through with a box that is custom built. And that's why I mean, if you have this view into, I can see what's under the hood while I continue to automate stuff, makes a lot of sense, because what is under the hood is not what these enterprise vendors like Google or Facebook will ship. They will ship something that is boxed, that's a kind of a black box, looks fancy, solves maybe 20% of your low-hanging fruit problems. So the other 80% is where you shouldn't worry about either. That's what I'm going to say. But this danger does remain, that there will be a hype or a shakeup at some point of a time where Google will announce maybe next year in their I/O or something that we're shipping a box calling AutoML, and I foresee that coming, definitely.
Yep, me too. So I think there's one question here in the chat. I think it's related to what we were talking about, I think 10 minutes ago, and it's from Andrew S. And he asks, Isn't it possible to merge them all, implement an AI, machine learning, deep learning? I am studying engineering and I believe that all these fields have great promise in the field of medicine technology. So I think when he says merge them all, I think he's referring to the point of merging research and developing solutions. And I think you asked you answered that just before, but maybe just if you want to add something, or Kristen wants to add something here.
Maybe Kristen, you can start.
So what the question was around or the merging of researching and data science?
Yeah, like researching data science and deploying solutions, being like the the engineering part of data science.
No, and I think that, everything is going to be towards moving towards being that well-rounded person, or the person who has like an intense desire to learn new areas and wants to go deep and can be flexible, so that as the market changes, you can adapt to it. And just back on, the automation that we're going to see coming soon, like the out-of-the-box solutions that I've seen so far, like the Salesforce Einstein model, I don't think that performs as well as, something that is could be built in-house. And, I think some things will certainly be automated, but there's just so many problems that can be solved with data and so many different questions that we're always trying to answer, that, a chunk will go away, but there will certainly be a chunk. There will always be chunks left.
All right.
Yeah.
So something to add, Terry, right now?
So yeah, I just opened up another page. I'm trying to read the question myself. So merge them all, implementing AI.
Yeah, because he asked that when I was talking about the part of research and the deployment of solutions, and I saw that.
Let me make it more interactive. So I see Andrew saying you are wrong, and
you're not wrong.
You're not wrong. Oh, okay. Oh, yes. You're okay. Definitely.
Like, who's wrong? Is it me?
Yeah. No, okay.
Yeah. I misread it. My apologies.
This is a great comment. I just want to read it because it's just so funny. It says, "I don't even have a computer right now, just a phone. It gets hard sometimes, but I'm confident I will be a data scientist."
Oh.
Yeah. Interesting. So I think, yeah, I can say that it's what Kirsten also mentioned as an example. I think you can provide labels and kind of make a nice fancy name called, there are lots of companies I know, even 2 years ago, 3 years ago, so they started with, christening their sort of machine learning, deep learning systems with, name of some researcher. I still wonder why no one has mentioned Ada or one of those, beautiful ladies who worked in programming back in the days. But I mean, besides labeling and giving us some fancy name to your to this kind of combined solution, there's still a whole lot of experimentation and differentiation that is required. So merging, I guess, it may not be a solution. I think what probably will be a solution, where we're working on a patent as well, is providing a cognition layer that tends to take away your big sort of, this whole bringing things together. For instance, if you're in the medicine industry, for Andrew, this question, I can provide some simple example. In the medicine industry, there are like hundreds of different domains within the medical industry. Now, I think the key is to merge things that make sense, for example, and creating different sort of, data set libraries, which is a huge problem today. So merging those and learning and doing transfer learning from those is like a super exciting area there, where you can spend years in the next decade probably, solving problems that have not been solved. And so I think from that perspective, there's some aspects of merging of data sets and learning from, we have text data sets in EHR or image data in medicine. So, and from another perspective, I think what will make sense of merging is, taking, like I just mentioned with a couple of papers we're writing as well, and we're building this we want to build a software layer in Deep Kappa, where we're trying to bring things like switching of, and reducing this complexity of hyperparameters across different layers. So from that perspective, it's also kind of merging. So there's a bunch of learnings which you need to apply from these different disciplines of machine and or deep learning. But I think a holistic a massive merge is not something we should worry about. Differentiation is going to be like super important. So I guess, yeah.
All right. So I think so people don't get confused. Data science is an amazing field. This has been quite honest from all of us, I think, and I think it's good to be honest with these things, because saying, yeah, don't worry, just stay where you are and be comfortable, it's never a way of improving your life. And I think getting out there and seeing the things people are building and just be active in the community and all of these different things. And I think it's time right now for you to get there and just start being, if you want, a data scientist. There's a question too. I think we have what more minutes to this, and this is, I think, a good question. And I think he says, how will AutoML change the data engineering and data architecture landscape? I think it's a good question, because it's not the same, and normally data engineers do very specific things that are related to hardware. So what do you think right now, or what do you guys think right now, this can change the landscape?
Yeah, I can maybe just very quickly summarize this. We have, I guess, another 7 odd minutes left. So yeah, I think we did kind of speak about this at large, about the skills, which will, so specifically, well, if you are a visualization expert, I think, yeah, you're going to have you already have a lot of tools, so that probably, will be less super exciting, while visualizing and explaining what you're seeing will continue to remain. A machine is not probably going to do that. Well, I don't know. In the next 2 or 3 years, probably I'll have to change my statement. You're just sitting next to a box and saying, well, explaining to the management how it's happening. And Mr. saying you're not needed anymore. It's like, okay, I'll stand outside. And the other is I think the value chain. Let me just kind of pick this up. I took a printout of this. So what I think is, for data acquisition, probably skills will be like exciting, but it'll go away as well. I think data preparation, feature engineering, model selection. Well, model selection is not a skill, but the whole exercise from data selection all the way to parameter tuning and all that stuff is going to be far more simpler and easier. Now, having said that, it's not an obsolescence of a skill. It is almost like making things easier for you, so you can, as a data scientist, if you're really super excited about doing 3 different things. For example, I really, really love autonomous vehicles and the medical industry. So for me, I have already picked up an ocean that is huge, and I'm saying, let me boil this ocean piece by piece. So I'm never going to get bored. I see there's a lot of people who are reaching out to me and saying, okay, we have medical data, can you help us? It's like massive. So there's so much request on Alzheimer data, sleep data, autism data, EHR, like I said, with 50 million patient data. So there's a lot of work going on. So specialization, so shift your specialization from focusing on your task, as in this is what I do as an expert and this is the pipeline. You move it up and start looking from a domain and industry perspective. So you become a domain expert in a massive field. you become an industry expert, understanding and learning maybe different things. So probably learning, maybe, revisiting biology, which I'm doing, which was not my favorite subject even back in high school. It's going to be like something which will be super exciting. So the obsolescence will happen in between, from acquisition, probably in outputting information into results is what AutoML will do. But what the augmentation of taking this and expanding it into different industry areas and probably new domain skills is the way you will sort of see the shift happen. And data architecture landscape is going to also change. Like I said, I think that people will be shipping also boxes for sure. I mean, there will be infrastructure startups who'd want to do stuff like this. So there, you will see some things happening. There's going to be a lot of investment in the VC community who will either take this and try to break this puzzle from an infrastructure perspective. This is, let's try to ship a box, and there's going to be a software solution, software industry. So there's going to be a whole lot of jobs there as well. So I think the data architecture landscape will also change dramatically. Maybe we won't be talking about data lakes and all those things which are like super exciting. Things will be far more easier, sort of, broken down into very simple, understandable pieces. Because right now it's super exciting and it's complex. We love it. We are scientists. We enjoy it. But I mean, the consolidation and sort of simplification process of how industries have sort of, spread and sort of, impacted, or meaning as it improved lives, is by simplifying your solutions. So as you go on simplifying your solution, you start diversifying and start improving your skill sets into different areas.
All right. That's a great answer. Okay, so I think this is it for us now. We'll be.
There's another question, by the way.
That's another question. Oh, it will create a framework of AutoML. Is it a supervised or unsupervised learning model? I will guess it's an end that gives a tuned model based on use cases.
Maybe Chris,
you can take this.
Take a look at it.
Supervised or supervised learning model.
Yeah, so my understanding of AutoML, which I don't know if people have a different understanding, but there's it would be moving to being able to automate all the areas of the pipeline. So, automated data analysis, automated feature engineering, automated model building. So, which could be, you sort of throw a data set and it's going to try all different methods of regression. It's going to try gradient boosting and tree algorithm, and output the results and say, okay, this model performed the best, and go with that one. It's sort of across the spectrum. Terry, do you have anything to add to that?
Yeah, I think
when we talk about the AutoML, hi, can you hear me? So
yeah.
the AutoML algorithm is not an algorithm, actually. It's like a system that will run you through different algorithms, and it will choose the best that describes best the data and gives better performances. And we mentioned this in the last session, but I think I'll just mention it very quick. You can go through different open source packages like Teapot or H2O, or AutoScaLearn, and there are very simple examples you can try these different libraries, so you can grasp what the AutoML part is actually doing. It's not like magic, and this code-based AutoML things are good if you're starting in the area, because it will guide you through the process from getting into data into a model. There are some Vue-based or visual IDEs type of AutoMLs that are great too, but if you want to get the feeling of programming and learning what these things are doing, you should check these different frameworks.
Yeah, like HyperOpt, sklearn, lots of other things are there. So I think it is definitely. So just wanted to answer so supervised makes a lot of sense. Unsupervised learning model, we're still far away. like I mentioned, the worldview kind of models, which people are not paying attention to, not for good reason, because it's still sort of research is releasing gradually to the industry, where a bunch of people in Google, I know, are releasing and also writing those researches. There's going to be a whole lot of sort of work going on there, as well as to, I don't know what I'm looking for, but I'm automating it to start understanding. So for example, a simple example of Google's I saw day before yesterday was trying to, and they're trying it on image data, for example. I think we're passing time, so I'll just sort of keep it very short, is that you start filling in scenes with things which your machine looks logical to put. For example, you see a view where you have houses and all that stuff, and then suddenly, you know, based on just your unsupervised learning as well, you're planting, as in the machine is trying to plant a palm tree and things, you know, seeing things in context. And that is kind of all automated process. So essentially, yes, they are systems where there's a whole lot of meta learning you're putting on top of that layer and saying, learn the big things for me. Do not start sort of doing those things in separations. And, you know, there's classification tasks, and there is, so you have all those stuff, you know, all these classifiers, you can sort of stack them up. And there's, you know, optimizer stack and all these other things. So I think essentially the framework will look different. They will look more simpler, but under the hood, obviously, there's a lot of learning going on.
Okay, so I think this is it. Now is it? There's a lot of things to say, so this is it's not always easy to end this kind of things. But okay, so stay tuned for next sessions. We will be releasing maybe in 2 weeks the next session of data science office hours. Thank you a lot, all of you, for being here, and for people watching this after it's been recorded. Just remember to subscribe to the channel so you can have all the notifications when we launch a new session. And you can ask questions on LinkedIn on the post we make, or if you have anything you want us to cover in the data science office hours, just maybe write us a message and we'll try to do that. So, all right. So thank you, Kristen. Thank you, Terry.
Thank you, guys.
Thank you.
Thank you for coming, all of you guys from all over the world, and it was amazing. And we're going to be doing it more frequently. I realized, you know, I've missed this sessions as well. You know, my travels and also building my own company was stopping me, but I realized I have to sort of be here. It's really important to work with, you know, Kristen, Fabio, and all the other beautiful guys who are right now not here, Bo, Kate, and all these, you know, beautiful people. So I think we're going to be back, and we're doing it more frequently. It makes a lot of sense. It's an important industry where, you know, DSOH is doing a lot of beautiful stuff. Thanks again.
All right. Bye-bye.
Bye, everybody.